Good morning, everybody. My name is Brian Germain, and I'm a professional skydiver and engineer. I design and build real parachutes. That's a big part of my job. It's not the only part of my job, because I write textbooks about it, and I teach special forces guys. I teach all kinds of people how to fly parachutes, how to fly their bodies, which is what you're going to do today, right? Learn how to apply science to your life. So this is what we call the STEM class. You guys know what STEM stands for? Yeah?
Science, technology, engineering, and math.
And math, exactly. All those things are really important for our future, right? For what happens to this planet. What do we do to it? It's up to us. And more importantly, it's up to you guys, right? Because in a few years, all of us will be retired and you will take over the world. So you have to understand how everything works, right? And that's about science. That's how you understand the truth. So science, technology, engineering, and math, and we're going to apply all of this stuff. But for me, it's all science. It's all your way of understanding. Math is your way of explaining the science, right? So you can predict something. And today, we're going to work on predicting fall rate, right? How fast an object will fall is something you can predict. You can actually do the math ahead of time and get a pretty good idea, and then figure out, well, my numbers weren't perfect, so why weren't they perfect? Let's see if we can go back into the math a second time. Why did it not fall as fast as I wanted? Well, maybe, for instance, the object has fuzzy things on it. We're going to put some stuff in the tunnel that has little things sticking off. It slows the fall rate because it adds drag. Slows it down. What if a skydiver dresses really skinny in a tight jumpsuit, or another skydiver jumps in a real floppy jumpsuit? They don't fall at the same speed. The whole point of this stuff is to solve problems, to figure out, well, what's a world problem? Anybody have a suggestion that we need to solve, that you guys are going to solve? What?
Try to solve world hunger.
Okay, world hunger is an issue, so we have to learn how to grow food better, right? In ways that actually leaves the soil healthier than when you started, which is not something we've been so good at, right? So we can create healthier food, not just food, right? That's a good answer. Other things? Yes?
Pollution.
Pollution is a major problem, right? Not just for us, but for everything on the planet. So we have to figure out how to, for instance, when you're driving your car that burns gasoline, how do you make sure that what comes out of the tailpipe isn't affecting the world? What about our power generation? A lot of our electricity in this world comes from coal-burning plants. We have to figure out how to filter that smoke that comes out of the plant so that it's clean, so that it doesn't hurt the environment. You have one too?
Global warming.
Global warming is a big one. That's huge. Some of those things might have had to do with our technology. Some of them might have just been natural trends, because we know there's like an ice age, and then it gets warm again, and it gets an ice age. So we have to figure out what we can do, our part, right? So what are some of those things that we can do? What about the fossil fuels that we burn? So we can figure out how to make electric cars and plasma cars. Your generation is going to invent all kinds of great stuff to solve problems that actually affect us and all the other species on the planet. So these wind tunnels, originally, the first one, I flew in the first tunnel in the world in Saint-Simon, Quebec. It had a big propeller. It was an old DC-3 propeller. They cut the tips off so it wouldn't be so loud, because the tips of a propeller break the speed of sound. And it's so loud. Some airplanes, when they take off, you're like, what is that? And all the bees freeze. It's true, actually. It's actually bad for the pollinators. They don't pollinate their things, yeah. So we've got these beautiful fans that are up there. It's interesting, they're actually up there. They're not below you pushing up. They suck the air up, they redirect it around these duct systems that change the direction. We call them louvers. It bends the airflow over a series of airfoils, just like an airplane wing. It bends it smoothly without turbulence, so we don't lose a lot of energy. And we don't have to heat it, we don't have to cool it so much. We have to cool it a little bit because there's friction, right? When you rub your hands together, you can feel it gets hotter. The air is the same thing. And so as the air goes around here, it actually warms up. And so we have a cooling system inside of these vanes that pumps water through there to cool off the air so you're comfortable when you're flying. So this is our flight chamber. This is what it looks like when you look upward, and you can see those louvers bending the air, changing it, and it forces it through there, and it comes around and another set of louvers, and then it squeezes it into a smaller chamber. What happens to a fluid, right? Fluids are both gas and liquid. What happens to a fluid when it's moving and you squeeze it into a smaller passage? It goes faster, just like the river gets faster when you squeeze it into a narrowed canyon. And then you go to a wider part of the river and all slows down. So we deliberately squeeze the air through what we call a venturi. Venturi effect is the escalation of velocity. You pick up speed, and so we don't need so much muscle to move that air at 120 miles an hour or 160 miles an hour. We can actually go in that tunnel, fly head first, and not go up or down, because we can adjust the speed of the wind. The driver, we have a pilot. And so that guy sits in the little box and he watches everything, and he communicates with nonverbal signals to the instructor who's with you, hanging on to you and giving you signals in sign language, because we can't talk. And he'll say, you know, they have this whole sign language, and they know how to adjust it to your speed, because I don't fall at the same speed as you, and you don't fall at the same speed as him, but you all have a readout on the screen. So each of you can look over, even when you're flying, if you're kind of heads up, you can look over and go, oh, look at that. I'm at 98 miles an hour, or I'm at 150 miles an hour. People always ask me, is it the same thing as skydiving? This is a tandem jump, we call that. On a first jump, most places you're attached to an instructor who's the one on the top and you're the smiling one on the bottom. Does it feel different? Is it aerodynamically different? And the answer is no. The difference is only that here the sky is what's moving and you're not. Does that make sense? So the whole air mass is created, we've created a motion, and so your terminal velocity will be basically the same. Your experience in terms of the maneuvering capability, it's the same. It feels exactly the same. It's just the view isn't quite as good as when you're jumping over the fjords of Norway or something, but it's still amazing. I have an interesting thought. You know the word engineering? Yes. You know what the jinn is in engineering? Jinn means genie. It does. And so engineering is you conjuring something like a genie out of nothing. You're coming up with an idea. What if I had a car that ran on electricity? What if I had, an airplane that worked in a completely different way? And then you figure out a way to make it happen. That is magical. So don't undermine the idea of engineering as, oh, it's boring. That's how this world is created. Isn't that amazing?